you get the YouTube channel?
So if you see this one, this is the original question that I made, where this is for 2 hours. Even though this is only, it's only 1 hour, the one that I did, and I explained like step by step so many things. Still it's 1 hour, but still I didn't want you guys to have all those.
There's something.
This was exam 1, the original one, but and I, for you, this one. Look at this. Those first question I removed it, and even but the solution I get everything. Okay, so don't get confused. Why? And this was not the question that we did, right? You see here. See this one is your question, right? This one is your question. So, and by the way, these were like 20 point initially. I made it 25 for you. Well, I'll remove this anyway. I don't know. Yeah. Yeah, and actually I have most of the video from other different colleges, which I did some of the problems. But thing is, there are some unnecessary things, students asking so many things, and those are not useful for you. So I don't want to post the whole thing, like long 2-hour video, So I need to edit, I need some time to cut those unnecessary things, and I'll post it. I just couldn't get time, but that's not an excuse. I'll definitely post it in a couple of days, okay? In 2-3 days. Okay, let's move ahead. Where will we is, okay, as far as chapter 8 is concerned, remember we need to finish chapter 8, but we are almost done, only a little bit left there. We need to finish chapter 8, and then I need to finish chapter 9 also, and we have only 2 days, only 1 day, and Thursday basically, at least last 15 minutes, I will give you some review, what you will be doing or what you expect in your second exam. Are you following? So basically, if I come here on time, if you guys don't bother me at the office for the office hour, right? well, again, I'm happy to help you, but even now I was like getting late, and then just one last one. So the point here is the first hour I try to finish. I'll start with chapter 9, and the first 1 hour, whatever section I can go on chapter 9, and then at least last 15 minutes I will use to review for your midterm 2. Alright? And those sections I'll give you like most important part of what we may be expecting. So without any further ado, let me. Yes.
On Thursday, will you tell us problems to go over like you did on the first?
Yeah, that's what I'm saying. So Thursday, last 15 minutes.
Okay.
Alright? And until then, wherever I reach, that will be your test. Okay? Of course, I may not be able to finish chapter 9 anyway, okay? But wherever I reach, so this one, let me. There are so many highlights, so very good. Looks like very sincere student, okay? Right? Good, Michael. All right. So, momentum conservation collision. This one, 8.3. What I do is, this one, the problem here, completely elastic collision. I want you guys to do it your own. Let me do it myself. One problem. let me do one thing. If you have one body of mass, give me mass, give me number. 2 kilogram, okay. Then another one, give me number. 5 kilogram, alright? 5 kilogram. This is going where? This direction, right? This direction will give me velocity. V, this one is A, right? Let's say A, this one is B. V of A1. A what? 10, okay, 10 meters per second. V of B, 1. What?
Excuse me, could you zoom in a little bit, please?
Oh.
Perfect.
Better?
Yes.
Okay, good. I'm like getting excited, so.
Professor,
Yes.
is this just a question you're making up?
I'm making up. Well, it is exactly the same question as example 8.7.
Okay.
But I don't want to use the same number. The same number one is done there, so you just see this. Alright? I'm just making up exactly the same number. This is like example 8.7. Alright? Like example 8.7. Alright. So now here's the thing. This, what is the velocity VV1? What's the velocity VV1? 13, right? Now if you say 13, that will be a problem. Okay, I agree with you, but the problem is, if it's going with 13, this guy can never catch this guy. This is going with 13, right? And this guy is going with 10. There's no way this guy will get this. Are you following? So there is no question of collision, right? Is that right?
Yeah.
But what I can do is, I don't want to embarrass you, alright, I'll take your 13, but what I do is, never mind, 13 is going this way. Will that be fine? Right? So now they will, of course they will meet, right? Isn't it? So now this I have to write here minus. Is that right? So velocity 2 is on the negative x direction, that's why I put it here minus. After a certain time they collide, let's say, they collide in such a way that they stick together. Alright. Alright, this is A and B stick together. Okay? Now the question is, I don't know where do they go. Isn't it? I don't know where do they go. Just after combination, it may go this way or that way. Isn't it? I got it. It goes where? On the left, right? On the left. Of course, because the mass is big here, velocity also big, so momentum is big, this one, right? If this was 5 and this was 2, then we may have to think, okay, I don't know which one, right? Are you with me?
Yep.
But since this is mass also less, velocity also less, momentum is less. This one mass also more, velocity also more, momentum is more, of course, isn't it? Is that right? So now, when they stick together, stick, S-T-I-C-K, stick together, it means what? They have the common velocity, right? So you are basically, when I say VA2 will be same as VB2, isn't it? Because they stick together, so whatever speed one goes, the other goes the same speed, isn't it? Right? This kind of collision is called completely inelastic. Why? Is the following. First of all, what was inelastic collision again? Who remembers? No. Yes, when the kinetic energy is not conserved. Very good. Are you following? In other words, the kinetic energy, total kinetic energy before and after is not same. Alright? So that is inelastic. Most of the collisions are inelastic, but this one is completely inelastic. This is completely inelastic because, look at the beauty. First of all, can you find the common velocity here? Your formula is what? M of A is A, right? And this is M of B. Okay, MAVA1 plus, what is it? MBVB1 equals to MAVA2 plus MBVB2. I can write here V, right? Because VA2, VB2 equals to V. Or I can V2 or V2. Since V2 is both same for A and B. Is that okay? Is that okay? MAV2A plus MBV2B, but those two are same thing, so I take that out. Are you guys okay? Alright, so can you find this guy now? All the information is given? Right? Can you find that guy? Can you do it quick? You do it yourself. Do it quick, in 1 minute. You have all the information? Do it fast. Do it fast. You can do, I know. I don't want to embarrass you because yes, make sure you have to, if it's negative, you have to put there negative.
Like the first
Negative 1.5.
we're getting the first two.
So did you guys get, what did you get velocity? Negative?
For A or B.
Negative 4.5. Okay, so what it means is, of course, our guess was correct because what we thought was it should go on the left, right? Isn't it? So negative means what? It goes on the left.
Negative 6.
Right? Now, this was easy. This was not a hard part. Yes.
For the first one is 2, and then for B is 5.
You got 6 points? 6, oh, somebody got 6 point something.
6.4. Negative 6.4.
6.43. Oh, what happened to that now? Is it 6.43?
Negative
Oh, okay, there you go. Whoever had an error, make sure you correct it, okay? Alright. So now, here's the thing. If you have velocity there, right? And now, well, this part is same as the previous problem, isn't it? Right? Which we did last week. But the question is, if you want to find the kinetic energy, the total kinetic energy before collision. What is the total kinetic energy before collision? 1/2 mass times A, velocity times A squared, right? Is that right? K1 of A plus K1 of B, right? Total kinetic energy before collision. I write here. So this one plus, can you immediately calculate this one very fast? MBV1 squared. Can you do this really quick? Really quick. Fast.
522.
523
23.
point something.
Yeah,
Okay, 23. This much joule. How many of you got the same thing?
We're still doing it.
that right?
Yes.
522.5. Okay, 522.5. All right. This is total initial kinetic energy. What is total final kinetic energy? Final kinetic energy is what? 1/2 of your now mass is both of them together, right?
You're down.
And then velocity, oops, okay, velocity square. Is that right? Total mass times velocity square. Is that right? Because when they stick together and moves with a certain velocity, now your mass is like combined mass, m1 plus m2, ma plus mb. And then velocity 2. What was your velocity 2? Velocity 2, how much did you get? What was your velocity 2? Solving, okay, velocity 2, you get 6 point, what was it? Negative 6.43. Alright, 6.43. So use your negative 6.43 and give me this number really quick. Total final. Oh, there's no friction by the way. Alright, yeah. In this case, there is no friction. What is it? 144.7. 144.7. Did everyone get the same thing?
Yeah.
Okay, very good. Look at now. The initial kinetic energy is 522, right? Right? After collision, your energy gets lost. Make sense? This is called completely inelastic, meaning your initial kinetic energy and final kinetic energy are not same. Not only not same, it is less than half. Are you following? Most of them are gone. So where do that loss in kinetic energy go? On the sound and heat and you know. By the way, the good thing, if they are traveling in opposite direction, it gets more heat and more sound, boom, right? More loss in kinetic energy. If you do the same thing, let's say, make this like 13 and this like 12, and going on the same direction, right? It doesn't make that big sound, meaning your final kinetic energy is still less, are you following? But we don't say completely inelastic. Are you following? There is only a small amount of energy converts to the heat and sound. Alright, a small amount of kinetic energy converts to heat and sound. Okay. Excuse me. Another one. This is light. I'll make it light. Light 8.8. Like 8.8. There's something called ballistic pendulum. What it means is you have a block of mass. Is a block, wooden block. Wooden block of mass. Give me a number. Okay, I like that 40. Big mass, right? Alright, big mass. Block. 40 kilograms. Oh, that's a huge. Oh, I think that's too big. I should have put a little smaller, right? What this guy has.
Really? Look it up. It's actually really cool.
The book has what? 4? What is it? I don't know where it is. Should be somewhere. Anyway, let's just make this number. Alright? Alright, let me make it 4.
4?
Yeah, and 40 is too big. 40 kilogram is almost my weight, right?
You sound different.
Almost your weight. 60. 46. Round up. Good acting for a few weeks and you'll be back to 40. Alright. Now, a bullet. Of, give me a mass. It cannot be 2 kilograms, come on, the bullet. 200 gram makes sense, okay? 200 gram. Give me the velocity of the bullet. Mass of the bullet and block will be the same thing, right? Look, hold on. What do I do? Block B and bullet is lowercase b, okay? Alright. Lowercase b for bullet. Alright. So the velocity of bullet is 500, 200,000. Make it simple. Make it 200. Okay, no, let me make it different. 200, 200. Make it 300. Okay. Alright. Now the question is, if you fire a bullet on that hanging wooden block, which is 4 kilograms, alright, hanging wooden block which is 4 kilograms, if you fire that, what happens is, the block will go high somewhere, right? Are you following? Now the question is, how high will it go? Are you following the question? Alright? How high will it go? Now here's the thing, these are just random numbers, so I don't know. I don't know myself. Sometimes if the velocity is too high, this may make a round. Are you following? So if it is too high, then that will make like circle, isn't it? Vertical circle. And following? So let's do with this number and let's see what happens, because it's just a random number, right? Let's see what happens. How you do this is the following. This is going with this guy. After it embeds here, what will be the velocity of the total thing after it embedded, right? This is same like this problem, just like sticking together, isn't it? Now it goes inside, it embeds there, it means now the total mass will be this. Are you following? Make sense? So first part of this is the common, you have to find the common velocity of both of them. That is same like this one. Your formula will be this mass times velocity, right? MB VB1, right? Plus MB VB, which is, this is at rest, right? Isn't it? Which is 0 anyway. Are you following? It is 0 anyway. So that 2 will be M1 plus M1 plus M2 times V, because common velocity will be there, right? Can you find common velocity V? This. Really quick. Mass times velocity, oops, okay. Find this V. All you have to do is mass times velocity equals those two mass times velocity, right? Well, the general formula is what? M little b VB plus mass of big B, V of big B, equals to mass of little b plus mass of big B times velocity. Is that right?
Is that a 4 or 40?
4.0.
Okay. Then it's 141.8.
What is it?
141.8.
141.
Yeah.
Oh, that's too high.
No, it's 14.
Do it wrong?
What is it? 14.3? Still that's too high. Okay. I think we should have gone with the 40. But anyway, that's okay. Our numbers are too high. What we could have done is, hold on a second. You know what, let's use the same number, don't worry. Okay, let's use whatever it gets, right? Because usually the common velocity of the block, will be only like 1 meter per second or half meter per second, okay? Or maximum 2 meters per second, you know, not that much difference. But anyway, that's okay. These are our made up numbers anyway. So you got your V, how much did you get? 14.3 meter per second. Did everyone get the same thing? Yes. Say it again. Show us how did you get?
How to do it.
Okay, really quick. So this times this, 300 times 0.2 plus, no, this is 0 because initially it is at rest. Right? And the total is 4.2 times 0, yes. So now, right. 14.2, right? How much did you say? 14.3. Yeah.
14.3.
28, yeah, that's 3. Right?
Yeah.
Okay.
That's the thing.
So now what? Now what? Now what happens? So let's say after 18 bits, this goes somewhere here, right? Oops. Something like this, isn't it? Right? So the question is, how high will it go? You need to find this height. Are you guys with me? Everyone with me? So now what happens is this kinetic energy, the total kinetic energy at this point converts to potential energy. Make sense? Make sense? So in other words, now what happens is 1/2 of whatever that this thing is, right? 1/2 of this guy times velocity squared will be m whatever gh, right? Does it make sense? Does it make sense? Actually, you can write this straight, but how it comes is basically K1 U1 equals to K2 U2. Are you following? So if you see K1, this K1, right, after it hits, isn't it? K1, but U1 is 0 because it doesn't have any height. Make sense? Make sense? And the other side is what? K2, basically that is at rest, at height, right? Are you following? When you have a certain height, so the velocity is 0 there. So the K2 will be 0, and U2 is mass times gravity times height, mgh. Make sense? So basically on this side, your potential, your U1 is 0. On the other side, your K2 is 0. Is that clear? No? Oh, okay. All right. You know this guy? You know this guy? What is K1? 1/2 mass times velocity squared? Is that right? So 1/2 mass is the total mass, right? Times velocity square, is that right?
Yes.
What is U1? 0, because there is no height. So U1 is 0 plus 0. Let me write tiny little 0. K2. What is K2 at this point? What is the velocity at this point?
0.
The velocity at this point is 0, right? Because here it swings speed and then slows down and stops and then comes back, right? So at this point your K2 is 0. 0 plus, what is U2? Mass times gravity times height. Can you find this guy? All the information is known. You know this guy. By the way, this will cancel. You don't even need it. All you have to do is V, you know the V, what is V? V, what is V? Hello, what is V? 14.3, okay, it's there, okay. So you know this thing, square, divided by 2, divided by gravity, that will be your age. So what is your age? 10.43 meter, right? 10.43 meter. Did everyone get the same thing? Did you all get the same thing? Yeah. Practically this is weird because you know how much is 10 meter? How much is 10 meter? Yeah. Say it again. Velocity at the both combined. Oh, you guys you got already. Use that formula, MD, VD, lower speed, and VD, and then plug all the numbers there. You'll get 14 points. Yeah, we can give it numbers. equivalent. Your n lower is b, natural bullet is 0.2 kilogram. 0.2 kilogram. You get that?
Yeah, that's what it is, but it's treating it as like it's saying it's not
What's not for you? 4.2.
divided by 300. I don't get the whole.
All right.
Divided by 4.2.
And there's one more thing. One more thing about elastic collision. In case of elastic collision, your total velocity will be 0. Okay? Let me repeat. Your total velocity will be 0. Total velocity means v1a plus v2a plus va1, what is it? va1 plus vb1, right? Plus va2 plus vb2, this will be 0.
What is that for?
That's for elastic.
So is that like a elastic
Yes.
specific question?
Say it again.
Is that question you did, is that a elasticity question?
Yeah, that's for elastic only. Let me do one thing. Yes. Yes. Right. Right, exactly. Actually, well, one of them has to be negative anyway. Hold on a second. Let me. It's written in this way, okay? By the way, this has a negative sign there, but anyway, what I'm gonna do is, let me do a little different way, okay? The one that the book has done, 8.27. So V of B2 minus V of A2 equals to V of A1 minus V of B1. So basically, VB1 plus VB2 equals to VA1 plus VA2. This is the real formula, okay? Actually, what happens if these two are negative there? I should have done here negative, whatever. This one, A1 and negative A1.
Professor,
Yeah.
could you scroll up a little, please, since we can't
Oh.
really see? Thank you.
Yes.
So the last problem that we did with the bullet was an elastic situation.
Which one?
The last, like the problem we just did.
Oh no,
Oh.
that's not elastic. No. Because when it imbears, when it imbears, that is completely inelastic. That's not elastic. So rather than using that the velocity, total 0, just use, because the sign of left side will be negative there, right? So you use this one formula, alright? The total velocity of one will be equal to total velocity of the other. In other words, total velocity of B or total velocity of A, total means what? Initial plus final, will be same as initial plus final of B in case of elastic collisions. Are you following? So there is one problem. Well, let me rewrite this. I just don't wanna do because because this one will not be in your. You know what? Don't do this. Let's do this. Elastic collision, as I say, E-L-A-S-T-I-C, elastic collision. As I say, what is elastic collision again? 1/2 of MA VA1 square plus 1 half MB VB1 square equals to 1 half MA VA2 square plus 1 half MB VB2 square. Are you following? Is that clear? This is for elastic collision. The total kinetic energy before collision, right? Is that right? And this one is total kinetic energy after collision. Does it make sense? Does it make sense? Total kinetic energy. All you have to do is, it's just like the momentum. The only difference here is what? In case of momentum, you have mass times velocity, MAVA1 plus MBVB1, isn't it? Equals to MAVA2 plus MBVB2. Is that right? That's the momentum formula, isn't it? But now the kinetic energy is same thing, only in case of, this is not always true. Only in case of elastic collision this is true, which is 1 half mass times velocity square of first one, right? Will be same as after collision, which is called true. So here is one problem here. Yeah, don't use this way, okay? If you do this way, this will be a little complicated. So just forget about this. Alright? Just do this. So here's one problem here. I'm not gonna do it because it's already 11:36, so I need to start chapter 9. Yeah, chapter 9 is the last chapter for until your exam 2. Right? And then I'll skip one thing, the center of mass, which is 8.5 for now. I'll skip this one because I have to do it later anyway. Alright? So for now I'll skip this. So only do until 8.4 for exam 2. Alright? So let me quickly explain this, and if you agree you can do it yourself, then I'll leave it. If not, I'll do it, okay? But I believe you will be able to do it. So here's the question. The question is, A has A1 velocity is 4 and B is at rest. When this goes and when they collide, alright? When they collide, one goes the one way and the other goes the other way. We have done this problem earlier. Is that right? Is that right? It has two equations. We have to get x direction and then y direction and etc. etc. Are you following? But the question here is, in the previous problem, one of the angle was given. Do you remember? Do you remember the problem? So last time the velocity was given as well as one of the angle was given. So the other one was this angle and this velocity, isn't it? Two unknown, we have two equations. Are you following?
That inelastic collision.
That was inelastic, yeah. The one that we did last week. Remember, we did one problem last week which has this velocity and this angle is given. You have to find out this velocity and this angle. Are you following? Like a billiard ball or something. Do you remember that? Billiard ball was at rest and then you hit it?
Yeah.
Make sense? Right, at something, right? Now look here. The problem here is there are three unknowns. One, you don't know this velocity, you don't know this angle. On top of it, you don't know this angle as well. So that's the problem now. You can have only two equations, isn't it? One is along x and another one along y, right? Right? You can have two equations. Two variables would have been okay. But in this case, what you do is, you have the clue here. It is the elastic collision. So elastic collision means what? Your kinetic energy is also conserved, isn't it? So that will give you another equation. Are you with me? This problem is same like last week problem for two equations x and y. Alright? But one additional thing here is, since it is elastic collision, so you have this equation also true. Basically what it means is, as I wrote in the formula, what is it? As I wrote in the formula earlier, MAVA1 square plus MBV1 square equals to this, right? But in this case, your second one is 0 because second one is at rest. This one is at rest. Are you following? So the question here is what? MAVA1 square plus MBVB1 square, which is 0 plus, you don't need to write that. And the next one is 1/2 MAVA2 square plus MBVB2 square. Are you following? Make sense? So that one extra equation there. Are you following? So once you have that equation, you can solve it, because from here it's, this is done here anyway. So you get your V2 from this equation, and then now do it same like before. Right?
Can you go back to the formula sheet?
Say it again.
Can you go back to that sheet where you wrote the formula?
Okay. I will leave this. Alright. I'll leave this because it's a little bit harder than what I did last time. The only difference here is you have now 3 variables and 3 equations. You have 3 things to find out and you have 3 equations. Alright. The algebra a little bit is a little bit different. Alright. So let me see if you can do this problem. If not, I will have one of them in the video, okay?
When are you putting up the video?
Yeah, some of them I already have, but I need to edit it, so I need some time to edit. I don't want to put like all the junk there. So with that, I'll skip this 8.5 center of mass for now, alright? So only until 8.4, alright? From chapter 8. Chapter 8, 8.1 through 8.4. No 8.5, okay? No 8.5 and 8.6 is also there, I believe. Yeah, 8.6, no rocket propulsion. So you skip 8.5 and 8.6 for now. 8.5 will cover sometime later. So with that, let me start chapter 6. Okay. Yes. Sorry? Yes.
And then 7.1.
All of chapter 6, 7 until where?
7.4.
7.4 I believe. I'll let you know on Thursday, alright? This is the rotation of lens body, huh? so far what we have done is, all the problems in linear, in only linear meaning only in one direction or 2D, 1D or 2D, alright? Meaning it's on the straight line, isn't it? If it was a projectile, then what you did was we broke that into x and y component, isn't it? Make it linear. Linear means only one line, okay? And then solve the problem. But now, this one is a little bit difficult, a little bit different. Not difficult, but different. Because now what you are dealing with is in a rotational dynamics. Meaning, now if you have a wheel, if the wheel is rotating like this, alright? When the wheel is rotating, remember the velocity keeps changing every second, right? The magnitude may be same, but the direction is different, isn't it? When the direction is different, what I mean is the velocity itself is different, and now we have an acceleration, isn't it? Are you following? So now a little bit of mathematics here. Let me review first of all. All right, a little bit of mathematics here. If you have a circle, you know the definition of pi, right? What is the definition of pi? Of the diameter. Circumference of a circle, let me write C, over diameter, isn't it? You can do it at your home. You may have done in your project in your elementary school or middle school, right? I'm recalling now again. Take any circle, right? Or any cylinder and bring a string or something, make it one round, and break that string and see the length. That will be the circumference, right? And then you measure the diameter of that ring, right? And when you divide your circumference with the diameter, you'll always get 3.14 something, right? If your pipe is like big, your diameter also will be big, your circumference will also be big. So your ratio will always be 3.14 something, or pi. Or in other words, your circumference is pi times d if you do cross multiplication. Diameter can also be written as 2r. Diameter is same as 2 times radius. So your circumference is 2 times radius. So 2 pi r, right? So this is your circumference. This is pretty simple thing, isn't it? It's pretty simple thing. Now, oh, you have a syllabus there? So it's up to what? Let me, since I saw the syllabus here, let me quickly see it. So, you have chapter 8, 1 through 6, but change it to 1 through 4, alright? Chapter 8, 1 through 4. You have chapter 9, 1 through 6, I don't know how far I can go, I'll wait. And chapter 7, it says 1 through 5. So, was it 1 through 1? We did until 1 through 4, okay. Chapter 7 also you do 1 through 4, okay? Yes. Chapter 6 off. Yeah, chapter 6, it's a small chapter, so you know, yeah. Oh. Oh no. No science sheet today. Everyone present. But don't go. Don't leave. Okay. All right. Now here's the thing. If you travel a certain distance from here to there, from point A to point B, all right, and you make an angle theta at the center, okay, this theta is called angular displacement. Remember, linear angular displacement is everything you go N-U-L-A-R. Angular displacement is theta. It should always be in radians, not in degree. Now, all right, your angular displacement is in radians. So if you travel from A to B, which is called S, is the linear displacement. Your S is linear displacement. Alright? Your S is linear displacement. Can anyone tell me the relation between S and R and theta? What is it? What is the relation between S and what is it? They are proportion, yes, of course, but relation between S and R and theta. Pi does nothing. What? Pi is circumference by d, or pi is this. 2 pi r divided by 360 is 2 pi. Yes, also s divided by theta. You can do that. So ultimately what happens? So this will cancel. You have r and theta left. Yes, exactly. S equals to r times theta. Very good. Are you following? In other words, let me make life simple. Let me make life simple. Your angle theta is s over r. Meaning, look here. Your angle theta is s over r. S is this distance over r. Are you following? If your S is circumference, by R, let me do this. If your S is circumference divided by R, then what will be your theta? If it is circumference S, then what will be your theta? 2 pi. Are you following? 2 pi. So your theta is 2 pi. Are you following? If your theta is 2 pi, your S will be C. Is that right? Your S will be C and R. So that's how your C equals to 2 pi R. That's how it comes. Does it make sense? Does it make sense? It's simple mathematics. Right? So the point here is S equals to R times theta. Let me do derivative with respect to t. ds by dt. What is r? It's a constant, right? R is constant. I put it up. d theta by dt. What is distance by derivative of distance for unit time? Velocity, which is linear velocity, remember. Alright? Is equals to r. What is the derivative of angular displacement? Remember, this is angular displacement, right? Angular displacement for unit time, I call it something called omega. Omega is called angular velocity. This one is called linear velocity. This guy is called angular velocity. Can somebody tell me the unit of angular velocity? Radian per second, right? Very simple, very good, right? D theta by dt, theta is radian, isn't it? Time in second, so radian per second. Is that clear? Make sense? So, if you do double derivative, what happens here? If you do derivative again, dv by dt. Here it will be r will be same, d omega by dt. Is that right? Is that right? So now what happens this one? This is called linear acceleration, right? This is r, this one is called alpha. This is your angular acceleration. Are you following? This one can also be written as, just like your velocity was, remember, your velocity was what? x2 minus x1 by t2 minus t1, right? Is that right? Something like this? Right? Similarly, your omega is what? Theta 2 minus theta 1 divided by t2 minus t1. Because this is your linear displacement divided by time.
Professor,
Yes.
for the omega, is that radians over seconds or?
Radian, yeah, per second, yes. Because velocity will be meter per second, right?
Yes.
So meter is the linear displacement, radian is the angular displacement. Are you guys with me so far? Right? So far everyone with me? Okay, very good. So now, here's the trick. Well, you can also write this. By the way, what is the, well, since it's the velocity, now what is the direction of omega? Because, excuse me, velocity has to be what? Direction, right? Isn't it? Angular velocity has to be direction. Whether it's linear velocity or angular velocity, both are vector quantity. And when I say vector quantity, the quantity must have a direction, isn't it? Alright? So velocity, it is very simple because your whatever is x direction, so x by t, right? So direction of x will give you direction of velocity. That makes sense, right? But here, in case of angular velocity, the direction changes in every second, right? Are you following? So what will be the direction of omega? Not to the center. Your acceleration will be towards the center because your force will be towards the center, but the velocity is not. The angular velocity is the following. If it rotates like this, look at my hand. Take your right hand, alright? When it rotates like this will be the direction of omega. So we call it omega z actually. You can write this way also. Omega, which is in the direction of z, will give you, you can write a limiting value delta t tends to 0, theta 2 minus theta, well, d theta, I'm sorry, theta 2 minus, write down delta theta by delta t, right? Change in angle by time, right?
That's the limit of what?
Say it again.
Is the limit of change over theta and
Okay, let me write it down here. Delta theta by delta t. Remember this one, velocity was what? Velocity was what? Limiting value. Delta t tends to 0. Delta s by delta t, right? Or delta x by delta t, whatever. This one was the definition of velocity, remember? Now same thing I go here. Remember delta t tends to the same thing. Delta theta, delta s is now delta theta. But here the direction is z, so that's the tricky thing. So in other words, if something rotates like this, let's say velocity will be in this direction, then your omega will be in this direction. Omega z will be up. As an example, if you open the door, if you push the door, this one, right? Now the question is, what will be the angular velocity of this door? I'm pushing this door, you tell me. I'm pushing this door, alright? If I push this door from inside, my hinge is on the right. That's the important thing, by the way.
Your what?
Hinge, the, what do you call the hinge, right?
Yeah.
This guy? If my hinge is on the right, and I'm opening the door from inside, alright? My hinge is on the right, I'm opening the door from inside. What will be the direction of the angular velocity? Of course, it is angle, right? Since the door hinge is there, it doesn't go straight. When you push, it goes this way, right? Right? It doesn't go straight. Is that right?
Yeah.
So what will be the direction of the, in that case, what will be the direction of angular velocity? Where? Is it up? Are you sure? Will be negative, yes. The reason here is, look, you cannot do this because your hinge is where? Here, on the right. So hinge is on the right, this is your door, right? Your door is going this way, right? Are you following? So when your door is going, your hinge is here, your door is going this way, means your direction of angular velocity will be down. Make sense? If, just a second, if you are outside, right? If you are outside, and now from outside you are pulling, right? Then from outside you are pulling the door. What happens now?
Positive.
Say it again.
Positive because you have four.
You can think of it like a graph, like it's going into the fourth spot.
Yeah, you can do that way, yes. Yes. Or anyway, if your hinge is on the left, what happens? Yes.
So like this.
What is the x? You don't need x, it's rotating, it's a circle. So if your door, if your hinge was on the left, right? The hinge was on the left, and you are opening the door. Now the door is here, your hinge is here, right? Are you seeing my hand?
So is that like a line?
It's like it's a Z.
Oh, so it's opposite.
Yeah, this is like XY plane,
Oh, so the x.
right? So if your hinge is on the left, then your omega is on top. Does it make sense? Yes? Okay. All right. Now, still 15 minutes. Yeah. Still 15 minutes. There's a simple question which I don't want to do it, but I'll just let you know. 9.1. Look at the question here. The angular position theta of this much meter diameter. You have the diameter, you can make it R, right? Right? There's a diameter, you can make it R. The flywheel is given by theta equals to this one. Just like x equals to something t. Remember? Chapter 2? Right? X equals to something. Now we have theta equals to something. Find theta in radians and in degrees. By the way, how will you convert degree and radian? Because 2 pi radian is equal to 360 degrees. Are you following? So let me quickly do it here. So one circle, complete circle. Your angle made in one complete circle is called 2 pi radian, right? I write at the time you will see on top, that is radian. It's same as in degree, you call it 360 degree. Is that right? So it means 1 radian is 360 degree by 2 pi. You divide both sides by 2 pi, right? What does that sound? Okay. This can also be written as 180 by pi. You multiply to both sides, right? 360 by 2 pi is same as 180 degree by pi. On the other hand, this is how you convert radian into degree. All you have to do is multiply by 180 and divide by pi. That converts to degree. In order to do 1 degree, in order to convert degree to radian, you have got 2 pi by 360, right? Just the other way. 2 pi radian by 360, which is pi radian by 180. So this is how you convert degree into radian. This is how you convert radian into degree. Alright? Either one of them. So now this question is a very simple question. Find theta and radian and degree in t1 equals to 2 seconds and t2 equals to 5 seconds. So all you do is, all you do is put t1 is 2, you get theta 1. Put t2 is 5, you get theta 2. Find the distance that the particle on the flywheel runs from t1 to t2. Find it in 5 seconds, in whatever. So if you want to find the distance, you have to do theta 2 minus theta 1, right? Are you following? So find the average angular velocity, same thing. Just like the linear thing, alright? Just like the linear thing. Average angular velocity will be, you get the average distance, which is theta 2 minus theta 1 divided by t2 minus t1. That will be your average velocity. Are you following? Make sense? So this is pretty simple problem here. Now, there you go. There's a picture here. Okay, right? Oops. So if it is going this way, right, your angle is up. If it is going the other round, your omega is down, right? And now let me give you a summary. Well, this general summary only, okay? One side I call it linear, other side I call it angular. Your velocity, your theta, linear is your x or s. Let me write s. Linear is s, angular is theta. Right? Your unit is meter, your unit is radian. Yes.
The right hand rule, is that the reason?
Yes, that's what right hand rule. Yes.
But why the water circulates in different directions in the north and the south?
Oh, that's a little bit different. A little bit different, yes. Because when you flush your toilet in the north hemisphere, and when you flush your toilet on the southern hemisphere, it will just opposite. Right? But we'll discuss that. Well, that's a little bit different. Okay, anyway. So the linear velocity we call it v, unit meter per second. Angular velocity we call it omega, which is radian per second. Linear velocity a, which is meter per second square. Angular velocity alpha, which is radian per second square. Alright? Linear we call it final velocity equals to velocity 0 plus a times t. Is that right? If you remember this one, right? Here we call it omega equals to omega 0 plus alpha t. V is called omega, V0 is called omega 0, A is corresponds to alpha. Time has no correspondence because time is same as linear. Time is time, it's a scalar quantity, so you don't need to worry about things. Or in other words, you can also write this like V minus V0 by t, right? Isn't it? Acceleration is change in velocity by time. That's how this comes, right? So alpha is also omega minus omega 0, change in velocity by time. Alright? This and this is the same thing. This is just a copy of this. Alright? Okay, the most beautiful and most general thing you may have already known, done several times. Your S equals to V0t plus 1/2 of at squared, right? Is that right?
Yes.
Your S, sometimes you write x there or y there and then you put V0y, right? Isn't it? Now what you do, S is what? What is S? S corresponds to theta, very good. What is V0? What is V0? Omega 0, very good. Come on, yes, you know it, I know. Plus 1/2, what is A? Alpha, what is T? T. Another one, V square equals to V0 square plus 2AS, right? Is that right? Okay, tell me, what did I write here? Omega square equals omega 0 square plus 2 alpha theta. Wonderful. Alright, very good. Tell me some more. Tell me some more. What else? What else? Give me some more. X minus x0, yeah, you can do that. What else?
The final equals V
S equals to, say again.
S equals to V plus 2 AF into X.
velocity? V0 plus V divided by 2. F is velocity times time.
Oh, that.
Is that right?
I was thinking about
Yeah, well, you said by 2, that's right, 1/2 of, right?
Yeah.
So 1/2 of this guy. So how about here? Theta equals to omega 0 plus omega divided by what else? Anything, any formula on your linear dynamics, alright, any formula in linear dynamics that has what? Distance, or also called x or y, isn't it? X or y, and the velocity initial and velocity final, two things, right? And then acceleration, and then time, isn't it? Out of those 5 quantities, if you know any three, you can find the remaining 2, isn't it? Out of those formulas. Are you following? Same thing holds true for the rotational dynamics. The only difference there is the direction is not as same as we have done in the linear dynamics, because in the linear dynamics your x direction was positive, isn't it? If your x is positive and your gravity is in the opposite direction, we put gravity negative. Are you following? Here is about your rotating counterclockwise. Usually counterclockwise is taken as positive. Alright? Sorry. Yeah, counterclockwise is positive and then clockwise usually taken as negative. Alright? So if omega goes this way, then yes, your acceleration will be up, right? Are you following? Or if the displacement is this way, angle is this way, then your omega will be up. If the displacement is the other side, counterclockwise, actually clockwise, right? If it is clockwise, then your angular velocity will go down. Are you following? So it will be just negative. So here, plus and minus sign, the direction depends on whether it follows the right hand rule. Let me take it that way. Alright? It follows the right hand rule. Yes. I'll come there. That's a very good question. Now the question is, what about mass times, what about the force? Isn't it? What about the force now? And that has to do something called moment of inertia. Can I do that? I have only 3 minutes, right? I think, can I do it? Okay. So here are the formulas. Can you see here? So in this particular case, remember as I tell you earlier, you don't need to do x minus x0, because whenever you start with the origin, right? Your origin means your x0 will be 0, isn't it? So origin, replace that origin as x will be 0 to follow what I said. So at the last one, 9.10 is easy. 9.10 theta minus theta 0 is nothing but theta. Your theta 0 is 0. So that will give you 1/2 of that thing. So I'm not taking your attendance today. If you have further questions, let me know. If not, today's attendance I will not count for your credit, okay? I'll see you next week. Yeah.